All right, so this video is going to cover problem number 3 here, another example of graphing rational functions with removable discontinuities. Okay, so our function is f of x equals x minus 2 over x cubed minus 4x. As always, the first thing we want to do is factor. Okay, in the denominator we can factor out a common factor of x, which leaves us with x squared minus 4, which is difference of squares. So the complete factorization of that denominator would be x times x plus 2 times x minus 2. Okay. So again, we need to recognize here that these x minus 2's cancel out. So my simplified rational expression here is 1 divided by x times x plus 2. Okay? So because these factors canceled out, that creates the removable discontinuity at x equals 2. Okay, we want to set those equal to 0, and it gives us a rational function with a hole at x equals 2. Okay? Because these terms are still left over in the denominator, we're going to have vertical asymptotes there. Okay, but first let's talk about the x-intercepts. The numerator can never be 0, so there is no x-intercept. And the denominator, when I plug in 0 for x, I get 0 here. So we're not going to have a y-intercept either. Okay, so this graph has no intercepts, which makes it a little bit tougher to graph actually, but that's okay. Denominator, I've got a 0 here, which would be 0, and this factor x plus 2. So we've got two vertical asymptotes, one at 0 and one at negative 2, okay? The degree of the numerator is less than the degree of the denominator, okay? So I'm going to have a horizontal asymptote at the x-axis, y equals 0, okay? So now we're going to go through our process. We need to determine behavior on the left and right side of negative 2, on the left and right side of 0, and then what's happening, how we approach the horizontal asymptote for the end behavior, okay? So first off, let's come at negative 2 from the left. So I'm going to go to negative 3, plug that into our simplified function up here, and we get 1/3, okay? So I want to get closer to negative 2 coming from the left, so I'm going to use negative 2.1, and when I plug that in, I get 4.762. So you can see that growing, it's still positive, so what we say as x approaches negative 3 from the left, negative 2 from the left, then y will be approaching positive infinity. All right, so now we want to come at negative 2 from the right side, so I'm going to plug in negative 1, which gives me negative 1. And then I'm going to plug in negative 1.9. Okay, I want to get right up next to negative 2 coming from the right. So negative 1.9, plug that in. And when I evaluate all that, I get negative 5.263. Okay, so as we're approaching negative 2 from the right, my values are negative and their magnitude is growing. So we say as we approach negative 2 from the right, then y will approach negative infinity. Okay, now I've got to deal with my second vertical asymptote. So we want to approach 0 from the left. So I've already got this value, negative 1, negative 1. So I'm going to use that again. Okay, I want to be just to the left of 0, so I'm going to use negative 0.1. And I'm going to plug that into my simplified function here. And when I do that, I get negative 5.263. Okay, so as we approach 0 from the left, it looks like we're getting more and more negative there. So we're going to approach negative infinity. All right, so now let's come at 0 from the right side. Let's plug in positive 1, and I get 1/3. Okay, 1/3, 1/3. And then we want to plug in 0.1, which is going to give me 4.762. Okay, so as we get closer and closer to 0 coming from the right, we're going to be approaching positive infinity. So as x approaches 0 from the right, y is approaching infinity. Okay, so now we just need the end behavior, what's happening over here on the negative extreme and what's happening over here at the positive extreme. So when we plug in a really large negative value, like negative 1,000, we're going to get a very, very small number. But the one thing we need to notice is it's positive. Okay, so as x approaches negative infinity, y is going to approach 0 from above. Okay, so we're going to be coming like this. Okay, we're going to approach 0 from above. Let's plug in a really large positive number like 1,000, and we're going to get another positive number. Positive, it's basically 0, but it never gets to 0. Okay, so as x approaches positive infinity, y is going to approach 0 from above. So I know on the left side I'm going to have a piece that looks like this. On the right side I'm going to have a piece that looks like this. In the middle I'm going to have, a third piece of the graph that we'll deal with in just a second. Okay, one thing to remember, the end behavior only has to do with the outer edges. Okay, what happens between these two vertical asymptotes is not affected by the end behavior. Has no relevance at all. Okay, So let's graph this function and see what we end up with. Okay, so the graph of the function f of x equals x minus 2 over x cubed minus 4x, all right? So once we simplified, we know we had a vertical asymptote at -2 and a vertical asymptote at 0. We also had a horizontal asymptote here at the x-axis, or y equals 0, okay? We're going to have a hole over here at x equals 2. We'll kind of determine where that is in just a second, okay? So first things first, one of the points we plotted, we were at -3 and 1/3, so just right there above the axis, okay? When we know the behavior. So the behavior approaching this vertical asymptote from the left, we were going towards positive infinity, okay? And our end behavior, as x was approaching negative infinity, we were approaching 0 from above. So that's what that piece is going to look like, okay? In between the asymptotes, we had a point, -1 was on the graph, okay? And the behavior approaching the -2 from the right was that we were approaching negative infinity, okay? So that's what that piece is going to look like, okay? And approaching the vertical asymptote 0 from the left, we were also approaching negative infinity. So this is going to kind of look like a parabola in there, okay? So that's what the middle piece is going to look like. Now on the right side, remember, we've got a hole at 2. I just don't know where that is just yet, okay? At point 1, I was up here, you know, just almost a 5, okay? And we know our behavior. Just to the right of 0, as we approach 0 from the right, we were going to positive infinity. So that's that piece right there, okay? We had a point 1, 1/3, so that's going to be around there. So our hole is going to be just a little bit less than 1/3, okay? So we come to that hole, and then we know our end behavior there was approaching 0 from above, okay? So let's plot that in. So the only hole here was at x equals 2. That's probably around 1/4 when we plug that in, a little bit less than 1/4, I think, okay? But that's the graph of the function f of x equals x minus 2 over x cubed minus 4x.